Hello and welcome to today's speaker series. Today, I'd like to welcome back Sergey Nazarov, co-founder of Chainlink. Sergey previously joined us back in 2020, where he talked about Chainlink's decentralized Oracle network and connecting to off-chain data. Since then, Chainlink has continued to build out their product suite, including the addition of their cross-chain interoperability platform, CCIP. So I think it's perfect timing now to hand it over to Sergey, who's going to give a talk on building the verified web with Chainlink. So over to you, Sergey.
Thank you very much, Frank, and great to be here again. Thank you for having me. So I'm going to assume that people largely understand the value of digital assets for this talk, and that they see the kind of direction everything is going in the market with fund tokenization, real world assets, and all those kinds of dynamics. So my assumption for this talk, separately from the previous talk, what my previous talk was about years ago, why digital assets, fund tokenization is going to happen. Now that it's happening, this talk is going to really go through some of the challenges to making it happen well, and how those challenges being solved results in basically faster time to market, more security, compliance, the topics that I hope people find useful and interesting for actually achieving the digital asset powered global financial system. So with that, I'm just going to kind of jump in. So there are three fundamental stages to the problem of digital assets that go beyond cryptocurrencies like Bitcoin and others. Fund tokenization, tokenization of real estate, tokenization of carbon credits. There's going to be a huge kind of panoply, a whole huge collection of various assets that go on chain that are going to get packaged into tokenized funds, real world assets that are standalone about real estate, all those types of things. But all of those more advanced assets will experience the first problem. The first problem is a data-related problem. So the data-related problem is around getting information into the on-chain asset, basically. It doesn't matter if the on-chain asset is a real-world asset about real estate, or a real-world asset about carbon credit, or a tokenized fund. All of them will share this same problem of having information, data attached to them. And Chainlink has put well over 12 billion data points on chain, powers the majority of DeFi, has enabled the transactions of over $9.6 trillion in transaction value through settlement around data and all those types of things triggering those transactions. So Chainlink, at the most basic level, is a data transmission and validation standard. And then if you think about it that way, then there's market data, identity data, but there's also cross-chain data. But the first problem is really around how do we create an on-chain real-world asset that has the necessary data to exist at all. So for example, if you make a gold coin, you're going to need proof of reserves. If you make a tokenized fund, you're going to need something like NAV or daily mark-to-market settlement prices or something like that. So all of these assets will not just be on-chain code that represent the asset, they will also be a continual stream of data going to that on-chain asset to allow it to function. And there are three examples here. One is proof of reserves. Proof of reserves basically proves that assets exist in relation to their on-chain contract. So the on-chain contract represents a gold bar, and the gold bar exists somewhere. Then there's identity. Identity is required for compliance with AML, KYC, and other parts of how transactions need to happen. So you want to attach identity information to assets so that they can be sent to counterparties. Without attaching identity data to those assets, counterparties won't be able to accept them because they don't have fulfillment of their identity and compliance requirements there. And then price, right? So that could be daily prices for mark to market, could be second by second prices to do settlement on trades or something. It could be NAV for basically figuring out the daily valuation of things. Any set of reference data, market data that assets need. What the world looks like now, I think, in asset management is there's a lot of disconnected pieces that take a lot of effort to connect together into a financial product, basically. And what the world of tomorrow looks like is there are these modular, separate on-chain pieces that are very easily connected. And those pieces will be pieces of contract code that can be combined into more and more advanced financial products, and pieces of data that feed that contract code with what they need to know in order to function. So those are the two really aspects of every smart contract: the on-chain code and the data feeding into that on-chain code in order to allow it to function. And Chainlink is the world leader in providing any kind of data, market data, proof of reserves, identity. We're kind of leaders in all those areas of providing the relevant data. So you've decided you want to make a digital asset, you want to make a real world on-chain asset that's going to be attractive to the market. Could be a real estate related asset, carbon credit related asset, tokenized funds, any asset will basically show these problems. You've created the on-chain asset, you've fed data into it. The next problem that you have is liquidity. How does this on-chain asset access capital from other places? How do other counterparties basically gain access to this asset in order to buy it? This could be a tokenized fund, could be anything, really any on-chain asset is related to this. The other thing that you've done is you've created what we call a unified golden record. This is something I talked about back in the previous presentation a few years ago, and it continues to be a very true statement and set of ideas, that what you're really creating is this on-chain container that has all the relevant information for risk management and for anyone to evaluate the quality of the asset just by looking at that container, right? That container houses all the details of the asset, all the relevant information, and that information changes as the world changes, so that on-chain container retains the information that people need to evaluate their risk. Now you're trying to get this on-chain container, this digital asset, this tokenized fund sold. You're trying to get it connected to other sources of liquidity and capital. This is where cross-chain comes in. So cross-chain is the solution to liquidity, right? Even if you make a very good asset, even if you make a great tokenized fund, if the counterparties that you want to buy that are on their respective chains somewhere else, then your tokenized fund and your tokenized asset might not be very successful. That's the basic problem. And there is now a huge amount of fragmentation among all the different chain technologies, and also a consistent pattern where nobody really is going to get on any single chain to do transactions on that single chain with anyone else. Everyone is going to have their own chain, because the cost and complexity of making your own chain work is going down. It's similar to the database business, where, decades ago, making a database work was a multi-million-dollar endeavor, and you had huge amounts of PhDs and other people that needed to get involved to get your database working in a mainframe in the basement. It was a really big deal. But then the technology got better, the scalability was improved, the usability was improved, and now databases can be spun up by a single developer in a matter of minutes. And that's how the database industry evolved. So the blockchain industry is going in this direction of achieving scalability by creating many replicas, so many copies of chains. And so banks will not only have one chain, banks will have hundreds of chains related to specific activities, just like they have databases related to specific activities. And not only will all those chains need to interface with each other across the different parts of the bank and the asset management firm, but they'll need to interface with all the other banks' various chains. And what this does is create a fundamental fragmentation of liquidity, which is solved in stage 2, right? So stage 2 is your ability to get liquidity, right? If your system has a great asset, a great tokenized fund, but it's not connected to other chains, then you're not able to get those counterparties to transact with your system, to buy the tokenized fund, to put assets into it. Your market size, your total addressable market is small. Whereas if you have efficient connectivity to all of the chains of all of the counterparties that you could ever want, your market size is big. It's representative of the whole market. So the second problem is, how do I get liquidity? How do I achieve connection with the counterparty's chain in order for their stable coin, their assets, their central bank digital currency, their whatever, to be used as liquidity to purchase my real world asset, tokenized fund, and so on? That's the second problem. Now, both of these two, the first two problems are sort of understood. The first one is pretty well understood because people are now making more advanced contracts. The second one, the cross-chain problem, is now starting to be understood. The data problem Chainlink has solved from the very beginning, from its inception. The cross-chain problem we're now in the process of solving, and we have live production usage that solves it in a secure way. But then there's the third problem, which many people don't fully understand. The third problem is what happens after an asset moves from the originating chain to the destination chain. How does that asset remain updated as it moves from blockchain A to blockchain B to blockchain C to blockchain D, E, F, all through the alphabet, right? How do you make sure that all the data, proving the reserves, making sure the identity is kept up to date, making sure price data is delivered for daily settlement, mark to market, and so on? How is all of that information flowing if the asset left the chain where it was originated? This is the third fundamental problem that Chainlink solves that few people understand, because many systems have not gotten to the point where they have this problem. We have been solving this problem for years because we're interacting with it on a daily basis on production for real value. As I mentioned before, the system has enabled over $9.6 trillion in transaction value, is on track to cross 10 trillion, I think, relatively soon. This third problem is actually very important, because if your goal is to create a unified golden record that manages risk, that gives all information about an asset and keeps that information updated and accurate, so that the buyer of the asset doesn't ever have to contact anyone, they could literally just read what the asset says and they could know everything about it. Then if that's your goal, then if the asset moves somewhere else and stops getting updated, your goal can't be achieved, right? So you have to build real world assets, tokenized funds, in a way that doesn't just take account of on-chain code, but also takes account of its relationship with existing systems, data systems, identity systems, your backend systems, CSDs, and various other systems that need to be synced with that unified golden record, and need that sync to be maintained as the unified golden record moves across various parts of the global financial system that's now turning into the kind of blockchainified, blockchain-based, blockchain-powered, but highly fragmented in terms of the technologies that it uses, global financial system. This is the third fundamental problem that Chainlink solves, and really Chainlink is the only system right now solving this, because it's the only system that does both data transmission for all of these categories of data and cross-chain connectivity. You can't solve this problem just by doing data transmission. There are people trying to do one piece of Chainlink's data transmission kind of value and part of the protocol. The vast majority of them are not succeeding because the security isn't there and the quality of the data isn't there and so on. But even if you were to solve a small portion of the data problem, if you don't solve the cross-chain problem as well, you're not going to solve the third problem of maintaining a unified golden record across all the different chains that it moves to. And you want that unified golden record because that's what makes all of this technically valuable and efficient. It's that you don't need to contact anyone to find out what the nav is, what anything is. Everything is proactively updated into the record itself. And that record is made in a way that as it's given from institution to institution, everybody can trust the accuracy of the data in there. So there's no need to contact anyone internally or externally to learn anything, because all the relevant information is in the record, and that relevant information stays there even as the record moves across different chains, different environments. And you want it to move across different environments because you want there to be secondary markets and liquidity. You want people to want to get these assets, to want to get these tokenized funds and these real world assets and digital assets and so on. This leads us to a number of other problems. How do we solve this problem? There's two levels to solving the connectivity problem. The first level is base connectivity to chains. So you and your systems, which are very well secured and very well understood, and people are very well trained on them, are not something that's going away. And there's no real plan or path, I think, to replacing them. I think there's a way only really to layer on additional connectivity, additional interfaces, additional interaction with other systems. And that's what Chainlink CCIP does, and that's what the Chainlink blockchain abstraction layer does. At the very base level, you have the question of connectivity. That question boils down to, do you want to connect to a multitude of different chains by integrating directly into those tens or hundreds of chains? which I can assure you is a very difficult process because the chains are constantly changing. The chain technology isn't super well documented. There's a huge amount of hurdles there. Partly, one of the only reasons we can even solve those hurdles is because the developers of those chains want all of those data systems and services that Chainlink provides. And so they're very active in integrating Chainlink into their chain infrastructure together with us. And that allows Chainlink to gain those connections that otherwise would be very, very complicated to create and maintain. So the first question is base connectivity. That's just the ability for your systems to efficiently interface with various blockchains. The second question is cross-chain connectivity. Cross-chain connectivity is about liquidity. And what you would ideally have is an interface, a single interface, that allows base connectivity, so base reading, writing, interacting with various chain technologies, as well as the ability for that same system to trigger cross-chain events. So that through that system, you could not only use your own chains and the various chains that you have across your organization, but you can use all the different chains of other organizations through one clear, unified framework. This is what the blockchain abstraction layer does. This is a specific part of the CCIP protocol and system that is responsible for base connectivity to all chains, public, private, central bank digital currency chains. The point of this is to create an abstraction layer between your existing systems and all chains so that your existing systems don't need to know anything about chains. They don't need to figure out how to integrate with chains, how to maintain integrations with chains, how to deal with reorgs, how to deal with blockchain finality, how to deal with all those questions. This is the body of work that we were initially doing with Swift as far back as 2016 in the first proof of concept that we had with them. And now we recently announced our second successful proof of concept, which expanded the blockchain abstraction layer work to also a cross-chain level of work, right? So with Swift, we were basically able to show that you can do three things. You can use existing infrastructure. You can use existing widely accepted standards like Swift messages, which, as you know, are very secure and widely accepted, have processed transactions very successfully for over 50 years and continue to be a very high quality standard in the security and ability for people to transact in ways that they both understand what the transaction is about. So it's a shared standard. We don't believe in replacing the existing standards or the existing systems. We believe in kind of creating an additional layer for blockchain related things. And that's what the blockchain abstraction layer does. And so with Swift transactions were able to trigger on-chain events. And those on-chain events were then able to be sent back into the Swift system in the form of Swift messages, right? So you can basically read and write using Swift messages. You can understand what's going on within a blockchain or various blockchains with Swift messages, and you can trigger events with Swift messages. Then there was also a component of this where you had cross-chain connectivity. And so that work was around not only how do we connect two chains using Swift messages, so existing infrastructure, but how does that existing infrastructure, through this connection, interface with many, many different chains, both public and private? And how does it actually trigger transactions across those chains using the existing infrastructure investment that you have with all of its security, compliance, trained personnel, and so on. So this is the fundamental goal of the blockchain abstraction layer. It's how do you interface efficiently with the massively fragmented, consistently evolving, consistently growing, highly fragmented, varied technology landscape of blockchains, which will only continue to grow in its complexity and variety. There will soon now be, I'm already seeing, vertically focused chains. So chains that are very good at one type of asset or one type of activity that are optimized for that activity, just like databases are optimized for a specific type of activity. And so the fragmentation and complexity of that is going to continue. One of the ways to think about CCIP is like the TCP/IP of blockchains. So TCP/IP generated a single way for the internet technologies that were fragmented and varied to interact with each other to form the internet. And that's what CCIP does. It creates a single messaging, communications, data transfer, and token transfer standard that allows all of the information across different chains, regardless of the chain technology they use, to be unified into a single network, into a single internet of contracts. And because CCIP is built with the ability to not only deal with token value, but also to deal with data, it can actually do both, which has very powerful features that I'll get to in a few minutes. The second fundamental problem beyond base connectivity is liquidity. No connectivity between chains means no liquidity. If you launch a great real world asset, a great tokenized fund, and you're not connected to all of your counterparties' chains, that is where they will want to transact with you from. It's like having email that isn't connected to the internet. You could have your own email system that you and people use internally, but if you can't email people outside of your system, that's where that system's value ends, and that's where its capacity to transact ends. So liquidity and cross-chain connectivity go hand in hand. And the real question with that is, how do you efficiently, securely, and with minimal risk manage that connectivity in a way that allows liquidity and value to flow into your system to basically purchase the assets that you create? Tokenized fund assets, whatever the assets are, you folks are basically, in my view, the window to all digital assets. And that window to all digital assets will need to be connected to all the places where, firstly, all the digital assets reside in order for you to get those assets into your chains, in order for you to combine them into the financial products that you want people to use. And secondly, for those financial products that you create on your chains to have access to the liquidity and value of others that you want to be your buyers, that you want to access your system. And you can also think of public chains in this way, because public chains are just another collection of net users, net buyers, more asset under management value that can flow into your system because you're connected to it. Fundamentally, CCIP is made to solve this. It's the TCP/IP of blockchains. It's an open source global standard that's becoming widely adopted in the capital markets, is also getting adopted in Web3. And so it's meant to cover both the Web3 public chain world's liquidity and value and the capital markets liquidity and value, and connect that liquidity and value into a single net of contracts so that your tokenized funds, real world assets, all of these systems and things can be connected to both your capital markets, existing counterparties, and the counterparties in the public chain world that might have additional liquidity or value that you want them to kind of spend on your systems. This brings me to the very important combination of messaging and tokens, token value. So there's the ability to move data, and there's the ability to move value, to move tokens. CCIP actually has both capabilities, and the combination of these two capabilities allows tokens to reach their destination and actually trigger the outcome or the transaction that they want to trigger. So what this means is, while historically you might have sent a message or you might have sent an asset and then some other system receives the asset and starts doing things with it, what you can do with CCIP is actually encode the instructions of what the asset should do into it. So you can take a stable coin, put it into CCIP, say, go to blockchain X, go to smart contract Y, and trigger function Z. And function Z could be the buy function or the deposit function or whatever function the smart contract has. And what that means is that you can remain within your systems. The way that other bridging technologies work is they force you to take your asset or your user's asset. Your user would be forced to take value out of, for example, their Fidelity wallet, put it in some kind of bridge system, use the bridge technology, go to the other chain, the chain of the counterparty, the chain of the bank or the chain of the real world asset tokenization system, take their value out of the bridge on the other chain in the other system, put that value in a wallet in that system, then from that wallet transact within the chain of the other system, right? So now your user that wanted to gain access to some real world asset, some tokenized fund, something, has taken value out of a wallet on your chain, moved it over a complex process, which has a lot of friction, and received it back out in another place where they now have to make an account. And with that account, they are now interacting with that asset over there, and they may or may not choose to send that asset back into your systems because, you know, there's some benefit to them to do that. That's how the current cross-chain world works. The way the CCIP programmable token transfer world works is from your systems, your users can define what they want to do on all other chains. Then the value that they have in your system is encoded with conditions about what it should do when it reaches the destination chain. Upon reaching the destination chain, it executes those conditions, because when it reaches that chain, there is a smart contract that can be executed. So we're using the programmability of smart contracts to create a really superior user experience. And this really comes down to this kind of personalization dynamic that you see in asset management, where people can say, I would like a tokenized fund that's composed of these parts from these different asset classes, and all those different asset classes are on their relevant chains. Well, now they can basically make that selection in your tools, in your interfaces, in your applications. And through CCIP, you can go and select all of the contracts and actually trigger the contracts without ever having to go to those chains. So this means that your users, your systems can retain control of value within, your chain and your systems, while efficiently interacting with not only the chain, but the contracts in the chain. And this is, I would say, one of the very big differences of how the CCIP system works. Is it's not just about sending the value somewhere else and letting it go away and letting it be somewhere else. It's about sending the value somewhere else with instructions that allows your relationship to the value and your user's relationship to the value to be maintained. And this is actually a very big difference for the whole user experience and for how everything will work in the cross-chain side of the world. The other big consideration beyond connectivity, beyond base connectivity, beyond cross-chain connectivity for liquidity, and beyond the ability to efficiently make programmable token transfers, which is what we just talked about, is risk management. Fundamentally, the capital markets are responsible for a large amount of risk management and compliance because of the huge amount of value involved. And I understand why that is now. I didn't understand that maybe 6 or 7 years ago when I started really actively working with the capital markets. But it makes complete sense to me now that when you have this much value and this much responsibility, you have to be sensitive to complying with various, not only legal frameworks, but even your own internal frameworks for risk management. And this is what the CCIP cross-chain system basically is built around. It's not just built around moving value or tokens and data. It's built around making sure that those movements meet certain compliance, risk management, and policy requirements. Those risk management, compliance, and policy requirements are managed through the risk management network. So the way CCIP is built is that there is a core protocol that is involved in the transactional throughput of the system. So what that part of the protocol does is make sure that all transactions are secure at a very base technical level in a very efficient way. So the goal there is efficient transactional throughput, what's known as a thin pipe in the infrastructure world. Then there is the risk management network, which is the smart part of the cross-chain system. Into the risk management network, you can encode various conditions. For example, do not accept tokens without identity data attached because I need to comply with my identity requirements. Or rate limiting for risk. Do not allow more than this much to go to a new address that hasn't gone through a certain level of, risk management or verification or something like that. Or it could be make sure that the CSD or the regulator that I'm working with or whoever that I'm working with approves a transaction before it has finality. Only then can that transaction be considered to have finality and to move to the other chain, right? So there's all these basically compliance, security, risk, and other policies that need to be maintained as value moves between chains. And the fundamental question is, where will those conditions be securely executed? They won't be executed in smart contracts because the people building smart contracts don't understand those conditions and don't really care about them because their goal is to make a successful smart contract that performs its function of a tokenized fund or a real world asset. But at the same time, you have this global systems problem of needing to comply with identity for all assets, needing to manage security risks, needing to comply with various internal policies around who can sign, who can approve, who can do things around transactions. all of these questions can't be pushed into the smart contract, and they shouldn't be pushed into a cross-chains protocol core portion, because every time you want to add something, you'll have to rewrite and update the core protocol. So Chainlink CCIP, the CCIP cross-chain interoperability protocol, is the only cross-chain system that has the capacity to manage these policies. And it's actually what the system is built around. It's not just built around sending value or data. It's built around sending value and data together to trigger things, and sending value and data together in a way where you can verify if the thing the smart contract wants to do is compliant with your global policies, which frankly is the only way I can see this working for the capital markets. The other way to think about this is that every system that moves value around in the world has a risk management component. Moving around value and moving around data that's valuable is not about just moving it and saying it's your problem. It's about managing various risks. And that risk management is what allows systems that move around value to be efficient and secure, and to have the user experience that people want because they successfully manage that risk. And so our view is that risk management, compliance, all these different policies are a core piece of how all cross-chain should work. So that's at a high level what this is about. Chainlink is really the only system right now that provides the data, the compute capabilities, which we didn't have time to go into, and the cross-chain capabilities that are necessary to comply with all the requirements for building a real-world asset, a digital asset, a tokenized fund, and to doing that through a single platform that maintains data connections, allows cross-chain to happen, allows the unified golden record to stay updated, and allows that to happen in a synced way with all of your existing systems. Here's a brief example with our work with ANZ Bank. It's a very large bank in Australia with over $1 trillion in assets under management. Basically here, there was a stable coin that was sent over CCIP and triggered a transaction to basically get a carbon credit. And that carbon credit was then returned back to the originating chain. So this is what I was talking about before, where you have someone in your system, they use your value, the value they have in your system, to trigger transactions somewhere else. And then whatever they did comes back into your systems, into your chains, so that your user stays within your environment. This, I think, is one of the key ideas. It's not how do you just connect to chains and have users move between chains. It's how do you have a secure, efficient, highly compliant way for users to interface with chains from your system, but for that interfacing with chains to allow them to stay in your system so that they are consistently interfacing with various chains through you, not by leaving and going to other chains. And to do that in a very secure, efficient way. There's more information on our work with ANZ. There's much more complexity here than I've explained, but at a very base level, this is just to show that this is something we already have working. You can trigger transactions in other chains. You can get back what was purchased through smart contracts on other chains and have that sent back onto your chain. And so I think the fundamental goal here is achieving that security and achieving that connectivity in a way where your users can interface with other chains without having to leave your systems, while also interfacing your systems with chains in an efficient way, right? That's really the challenge, is how do you achieve that efficiency of integration, efficiency of connectivity, while allowing the user experience to be the user experience that retains that user value, the assets under management within your systems, without it necessarily, like, the value can leave your system to get more value and then come back, rather than leaving your system and being somewhere else. And to do that, you need an efficient infrastructure that can execute that type of relationship between your systems, your chains, and all the other chains where the liquidity is, where the users are. And once again, those chains will not just be private bank chains eventually, they will also be public chains. So there will be a very big consumer world and a big mass personalization movement from the consumer world in public chains, as well as in private chains, where those consumers are living in those private chains as being part of that institution that holds that chain.